Hi and welcome to this video called Basics of Plastic Part Failure Evaluation in Injection Molding. I've structured this video in 3 parts. First, we will discuss the types of plastic part failure in general. Second, we have a look at the areas of part failure in injection molding. And third, we will have a look at the failure analysis itself. So let's start with the types of plastic part failure. In general, we have 4 major types of failure. These are mechanical failures, thermal failures, chemical failures, environmental failures. Additionally to these 4 is also time, because a combination of chemical and time can also cause part failure. So in the mechanical failures, you have to imagine the result from excessive application of an external force such as a tension, compression or impact, and if such forces surpass the yield strength of a material, the part risks being deformed, fractured or completely broken into pieces. In thermal failure, here for example high temperature can warp, twist, melt, burn the part, and low temperatures can turn plastic parts more brittle. With chemical failure, here we have again chemical reactions can lead to a breakage of single bonds, and molecular weight can go down, and this is especially then amplified when a part is subject to elevated temperatures also, or if there is already existing stress in the part. Environmental failures, here we have we can consider everything from humidity, ozone, ultraviolet light radiation, pollution. They all are causes for environmental failure. Okay, so now we go to the areas of part failure in injection molding. So we can again separate into 4 major areas. The first area is the pre-molding area, as I call it, which is mainly the material handling, storage, and material preparation, especially the material drying. The second area is the molding itself. So here the cycle conditions. So are the melt temperatures okay? Are the tool temperatures okay? Injection speeds are set right, and so on. The third area is everything what happens after the molding, so the post-molding phase. So this is handling, finishing the part, assembly operations, and also packaging can be an area where part failure then can occur. And the fourth one is the application area, so the end use and environmental factors. This is what we discussed before with the types of plastic part failure. Okay, now we continue with the failure analysis itself in injection molding, and we can say there are 2 types of defects in injection molding. So we have molding defects and molded part defects. So molding defects is everything which happens during the injection molding, and molding part defects are defects identified after the product is produced. For example, for molding defects, we can have short shots, air entrapment, nozzle troll, cracking, and molded part defects, for example, is jetting or flash or bubble formation. So now it is important also to pinpoint the problem, and for that you make a failure analysis. So there are different root analysis tools. Famous one are the fishbone procedure, the Ishikawa, or failure mode and defects analysis, the FMEA. There's also the Pareto technique or the 5V, the 5I technique. So basically the questions you need to answer are: what type and grade of material was used? Does the part match to print? So really compare it to the drawings. Basic question like, is there wear in the tool? Have there been any changes to the current molding machine and the process setup? Has chemical exposure been a factor, for example? So important is to conclude here that the causes and forms of part failure can vary. However, you need to have a systematic evaluative approach which can help you to diagnose and rework your part production process. Okay, this is the end of the video. Please let me know what you think about the evaluating of plastic part failure of injection molded parts in the comments below, and looking forward to next time. Bye.